All right, everybody, welcome to the RTOP first day of September 2024. A couple announcements. We did send out a 2025 renewal notice. Right now we have, Tom Jacobs has been doing a fantastic job, and I have been going through the database, and we deleted all of the. We started with 1,700 people that's in the database, and we're down to 652 which includes all of the people that duplicates, things like that, life members, honorary members. And when we've updated that, then we figured out who has been paid and who has not. And we sent out a renewal notice to everybody to renew for 2025. And the numbers are that we currently have 652 subscribed members. Of that, about 190 have paid for 2025. So about 480 people still need to renew their for 2025. After December 31st, I'm probably not going to send it to anybody that hasn't renewed for 2025, because theoretically they should be renewing in August, September, October timeframe. But we're just catching up with the database, and so we're going to wait till about December 1st or 31st, probably January 1st, 2025, before we start not sending notices to people that have not updated their thing. So you guys got a window in there before we stop updating. But there's like 480 people that are not currently updated, but we just sent the notice out, so you have time. We'll see what else. Okay, and Andrew's got I think we're getting a lot of people popping in, Andrew. So did you want to go and try to do your thing now, or you need some time to set up?
I suppose the big question is whether Ted's online. Oh, he is. I can see he's there.
Here
I guess the other interesting person who would be particularly interested would be Alex. Is Alex around?
I would suggest Dennis talk first because he has to leave.
Good idea. Very
Okay.
well. That one.
Well,
Dennis, go ahead.
I'm really appreciative of this new effort to have this meeting on the first Sunday of the month, and help express to all of us the different issues involved in getting a signal and recording it and knowing what you're seeing. So I really am looking forward to that. I do have to leave though, and something was set up, family and everything, so I'll have to be gone. But I did hear them say they were starting the recording, so I'm saying okay to that, and I hope all goes well, and I'll get to the recording and see what you said later. Thank you very much. Appreciate your efforts.
Rich is on mute.
All right. Anybody else got anything? Thanks, Dennis. I've been on mute. But anybody else have anything real quick? And I'm going to go to Andrew and see if he wants to do this live demonstration, since this is an observation party. He's got a live observation he wants to show off.
Well, I don't know if it's going to work. I just thought we always keep talking about easy radio astronomy, and not everyone's seen it. And I thought it might be nice if we can actually show it working, which is possibly a big ask, but we'll have a go. Now, how do I share the screen again? Share, share, and share the screen. Okay. So. Is it showing my my remote access screen there? Is that coming up?
We see the color in the bottom left. Yes.
Ah, that's good. That's good. Yeah. I'm never quite sure what other people can see on these things. So, oh dear. So many hovering boxes here. Right, so this is my my remote access screen. I mentioned before my my
Now, the
stack.
problem is you brought up a new window and we're not looking at it.
Really, what can you see at the moment?
It says all connections below the car.
Yeah, that's what I'm hoping you should be able to see.
Sorry, carry on.
Yes, we should be able to see. So I mentioned before. I've talked about. I've got my stack, which is a stack of mini PCs. So you'll see on the screen it's all connections. And it's got LRO, stands for Liquid Radio Observatory, and then you can see a whole pile of connections: LRI, Alex Pettit, LRO interferometer, LRO magnetometer, etc. And each one of those is a mini PC, which is running one of the experiments, radio experiments that I've got going, which makes it look like I know what I'm talking about. Ha ha ha! How silly. So, what I thought I'd do was just pull up and just show easy radio astronomy. So here we are. Can you see where it says easy radio astronomy data collector? Is that appeared on the screen?
We see the new charts. Thanks. Easy call.
Yeah. Hopefully, Ted, this is the right one now, because yesterday I tried to download the latest update.
Well, there's a newer one that has new buttons around azimuth and elevation. This will collect correct data, though.
So I mean, I got this off GitHub. I went there, and this was the one that was on there. Should I be having a newer one coming down from GitHub?
I thought there was a newer one. I'm going to have to go look.
Oh, well, okay. So this is for my Farmagon array, which is a 4x4 array of dipoles in what's called military band 3, which covers the hydrogen. So this is now collecting the samples. You can see on the screen that it tells you what azimuth it's set at and the elevation, and other sorts of bits of information, of which one bit is this thing that says EZ col integ QTY, just below the buttons that say new plot, and there's something next to it. And it's got it set as 31,000. So what that's doing is, if I understand it correctly, and Ted will correct me if I got it wrong, is actually integrating 31,000 sort of data points that come through from the software defined radio to create a single sort of measurement which goes to the data file. And then below this, the other thing I find quite interesting is you've got these various graphs like this blue splodge. Never quite sure what blue splodge does, and I've got a red splodge down the bottom, and I'm not quite sure what red splodge does as well. But in between, we've got light blue zigzag line, and the reason this is zigzag is because the way this has been set up, it actually takes a sample reading at 1420.405 megahertz, which is a bit laughable, the assumption that my software-defined radio can give us that amount of exactitude, but still, no. And it takes that one sample, and then it takes another sample, this time 3 megahertz away from it at 1423. In fact, if you look at the top of the screen, just under the title, which is EZ230406A.by, just below that, you can see it's got freak center reference. So that's the reference sample, which is 1423. And then you've got frequency center, which is the actual main data sample. So it's taking every other sample 3 megahertz away. And the reason it does this is because you don't get hydrogen at 1423, so it acts as a reference sample. And we can take one from the other to act as a reference without needing a separate 50 ohm reference to switch in and out. Although I believe that EZ Col will do that if you want to set it up that way. And also the advantage of this as well is because you're doing every other sample, it means as the whole system changes through the night with temperature, or the day for that matter, with temperature and humidity and everything else, then it's changing for 423, and it's also changing for 1420. So it's affecting both reference and the main SAM data point, and therefore hopefully giving you better calibrated data. Now, if we go back to the red zigzaggy line on the left-hand side, which is the main data that's coming through, for people who've never seen hydrogen data coming through before, I know there are some people who may have done many amazing things, perhaps never quite got around to doing this. When they get to it, they wonder what they're expected to see. So on that, the first thing that's worth pointing out is there's a lot of interference, because we've got lots of pointy lines going up and pointy lines going down. But if you look around 1420, you've got a dotted green line there, which gives us the sample line. And at that point, you can see there's a slight sort of hillock, which is occurring just either side of the dotted line, if you sort of do a trend line through that. And that's the hydrogen, that little hillock there. It's not a straight single point that goes up, which would be, if you saw that, that would just be interference. It's actually broad because you're picking up a range of velocity measurements that are being picked up together. As you can see, every few seconds this is changing. So this is doing it about every 3 or 4 seconds. It's actually collecting a data point. And we've had a lot of discussion on the SARA group, and also outside the SARA group as well, about the benefit of how long you integrate for. And I'm not sure I've actually, in my own head, really got to the bottom of that question. But you can change this by changing this EZ col integ quantity number, which is below the little yellow boxes at the top right-hand corner, from 31,000 to other figures to change the integration time, if you so desire, and to see what effect that has. So if you just bear that in your mind for a second, I'm going to just close this down and then reopen it again. And you'll see why I'm going to do that in a second now, because I've got 2 hydrogen experiments going in the garden doing sort of the same thing. One is the Farmagon array, and Farmagon arrays are very rare, virtually impossible to get hold of. So they're not a great choice to recommend to other people. But the other one I've got is Alex sent me one of his neat little new plate Yagis, which, if you haven't heard of them, he's been making these plate Yagis, which you just comes as a bit like an IKEA setup, with a box full of little bits that you sort of screw together, and you have to find yourself a long screwed piece of threaded steel, which you put in the center, and it comes with some nice instructions and great support from Alex. And you basically just follow the instructions, and it pops together, and you have a nice little neat aerial, which is significantly smaller than the Farmagon array, and has the advantage that you can put it on a much smaller mount. And if you do want to then track something, it's of a much smaller, more practical size to allow tracking to occur. And one of the questions I've been trying to answer, or at least I'm interested in answering, because you can on these things, is whether that outperforms the Farmagon array, which in a minute I can show some results from last week. We're trying to answer that question for the first time. But at this moment in time, I'm now trying to do something a bit different with it, which is I'm trying to actually find out whether changing the integration time, what difference that makes in terms of the sort of plots that you get. And in my case, I have a particular desire that I want to achieve, which is I'm really keen to try and get more detail in the arms behind the arms. So, when you look out into the galaxy and you start mapping the Milky Way, you get a nice bright arm in front of you, and then you start to get data coming through for the arm that's behind that. And I'm keen to try and get more detail on that arm. So this one, the last one was 31,000 on the integration factor. if you look at this one, I've gone stark staring bonkers, and it's 1.2 million, which equates to roughly 3 minutes. So this is an attempt to actually integrate over 3 minutes rather than over about 4 or 5 seconds. And we'll see what next time we're in one of these meetings or Drake's Lounge, I should be able to show you what the effect of that was. One immediate effect I've seen is that the size of the data files that are produced, it's absolutely dramatic. The sort of standard setup with 31,000 on Easy Radio Astronomy produces some very large data files that take a long time to process, whereas this is now producing relatively minuscule data files. So much easier to process, so much easier to store. But it'll be potentially, I'm expecting to lose resolution in terms of resolution on the sky. A question to me what difference that makes in real terms. But I'm hoping that I will instead gain sensitivity and signal to noise ratio, getting that arm behind the arm, so get some data out there. In other words, better bit depth for each pixel, effectively, to do a comparative term with astrophotography. Again, if you look at this diagram here, and you can see the peak there, the hydrogen peak in the middle. It's not the spike that's going up. It is the broader peak around the 420.5 area through the green dotted line. As you can see, it is peaking up above the sort of baseline that's there. Now, I mentioned that I got some data to show, which is from this last week, for about 4 days at a time, to both setups going Farmagun, both at 31,000 on their integration, so about 3 or 4 seconds per data point, both pointed towards 163 degrees azimuth. And then a drift scan collects the data across the sky, and both at around about 77 degrees elevation. Because my mounts are rather simplistic, it's very difficult to get them to be exactly the same. So I think 177 and 173, but I use an inclinometer to actually measure the exact elevation once I've set it up to the best of my ability. And now, so pulling up some data to show you what we've got. Where are we? So this I'm going to pull up now is the graph showing observations for over that time period. Can you see it? A graph turn up a nice red line with a couple of peaks on it on a Milky Way background. Has that appeared on the screen for everyone?
We see the ANT-B plot.
Yeah. So so that's this is for the Farmagun array. So let's put that there, and let's see if I can, to compare with that, bring up the Yagi array. Now, so bear in mind, both of these are taken over about 4 days worth of data. Both of them are using Easy Radio Astronomy to collect and process data. So there's no difference in the two. Both integration time of 31,000, both pointed roughly in the same direction. And the idea is to see whether the difference in the aerials made a significant difference. So where are we? So there we are. So we've got the Yagi on the left-hand side. We've got the Farmagun array on the right. And what I notice is, with my simplistic brain, is we seem to have an awful lot more peaks on the Yagi than we do on the Ptarmigan. The Ptarmigan seems to be just basically showing us 2 peaks where it crosses the main band of the Milky Way, whereas it seems to me that the Yagi is starting to show us some of the major galactic radio sources as well, or at least even extra-galactic radio sources starting to show up on there as well, which suggests to me that probably the Yagi is outperforming the Ptarmigan, but I'm happy to be corrected on that and be very interested in other people's opinions. That's me done.
I have an opinion.
Go for it.
You're using a simple calculation here using Ant B. There are fancier calculations that remove some of the additional noise on the signal. There are a lot of frequencies that are not hydrogen, and why should they be adding to the average and then getting plotted here? And I think that's what we're seeing with the bumps in the middle.
Right.
I can show you the plots that I came up with for you so far, and his antenna looks better. The signal you're getting from Alex's antenna is weaker than the ptarmigan, and I'm not quite sure why. For all we know, it could be a loose connector or something like that too.
Right. So are you trying to share your pictures? Should I stop sharing?
Not yet. If you want to unshare, I will share mine if you want.
Yeah, I'd be quite interested to see that. I mean, certainly Alex has asked me to do a particular observation over 24 hours, which I'll do a bit later in the week and send to him, and he's going to then do some comparison with what he's picking up, so we can see how well my particular aerial is performing compared to his expectations.
I have to bring it back up. I had to turn on my mic. Okay. If we look on the very top left, Andy, is that Alex's antenna? I think so. It says Yagi.
Oh, yeah, that's right. Yep.
Okay, so with more processing and using more processing in EasyCal on all the data, I got these 2 bumps, which is simpler than your more bumps in the middle. So I removed a lot of frequencies that are just not helpful, and that gives a clearer image of what the hydrogen is, and it looks pretty good. Indeed, your ptarmigan array looked much stronger. Can I find that here real quick? Let's see. Probably. If I do this, let's see. No, I don't have that one loaded up. So your ptarmigan array has a stronger signal and gives a better plot of power across the radio sky. That's not a surprise. So now we got to figure out what's going on with the 2 antennas in that way as well. But this plot looked a little bit better than what you had up previously.
Yeah, I mean, I wouldn't be surprised if there's an issue with it. I mean, I'm hardly experienced at putting aerials together, and I could quite imagine that I've got a poor connection or haven't soldered it properly in the right place or whatever.
Well, I'm thinking it's more like the Alex array currently is picking up signals from the side. When we looked at your plot earlier, it had some spikes up and down in the top left there, showing that local transmitters are causing trouble. Anyway, thanks for showing all this off. This is good.
Yeah, well, before we leave then, I'll just pull up the, if you close down your sharing, I'll just pull up the ptarmigan array again, and just before we finish, and look at the live one, and just see whether there seems to be an obvious difference in terms of interference coming up on it. Where are we? Perhaps it's difficult to tell.
So here's the ptarmigan array. And maybe I see some spikes over on the right, but they're not as dramatic as on the Alex array at this point.
Okay. Well, thanks very much, Ted. We really appreciate that. Thank you.
Thanks for your show. Now, on the bottom, we can see temperature changes. 9 hours ago or so, it's probably got started to get cooler. Would that be right? Or warmer? I guess warmer during the day.
Mm-hmm.
So okay, we can and what the key here is that the top and the bottom of that big red thing at the bottom, that strip chart, act the same, and therefore I can use one to remove the temperature effect from the other. That's the idea of the reference samples. Carry on.
I think it's a brilliant idea. I still got. I mean, there's so much in this software, and it's like a constant voyage of discovery for me. Trying to, especially start hitting the settings and having a bit of fun changing it and see what then happens and how things change. So yeah, a long way to go. That's the fun of it. So thanks very much. Is there anybody else like to make any comments or thoughts? I'm open to anybody's thoughts or ideas.
Now, Andrew, you had a mount that you were going to mount his antenna on, and you probably have already. But that mount is from an optical astronomy, and it could actually track stuff across the sky, right?
I haven't got as far as that.
And so now EasyCall, that program he pulled up, has a way to point at a right ascension declination location, and all it's doing is recording it. But at least it's Ezra now knows how to do that.
Right.
I'm
Okay.
not sure I've even done it. Maybe I have.
So that would just maintain it staring at the same right ascension and declination constantly throughout the observation then?
Because of the motors on the mount, correct.
Yeah. Okay. So I guess you'd use the mount to keep it pointing at that point, and then you'd just be telling Ezra that this is where it was pointing throughout the observation.
If that's helpful. That would be helpful to Jason if he had a mount with motors so that he could track his external galaxy across the sky and get data even faster. And so Ezra's ready to do that now. Motors are the trouble.
The one thing that I'm never quite understand, Ted, is with this business of tracking, what advantage do you get by constantly pointing at the same point, say, opposed to the drift scans?
Well, Jason's trying to get data from a galaxy, so that's one point up in the radio sky. And instead of getting a couple of minutes every day, if he could get 15 minutes all at once, that would speed up his observations. So that's one thought. What I wanted to put in was so that we could now do raster scans across the sky and zoom in on a particular area of the radio sky and study that.
Okay.
Anyway, I'm thinking higher. When you get the later EasyCall, you'll see some new buttons there. The latest one is from July of this year, and you're looking at the one you had up there was from April of 23.
Okay.
So many things.
Okay, thanks very much. Thank you.
All right, excellent. That's the kind of stuff we want to see, live stuff for our observation party. I'm going to go to the time zone challenged people. So Robert Lucas in Australia.
Hello, everybody. I was hoping to, be able to, send some data with Alex's, antenna, but that didn't happen this weekend because it was very clear out at the observatory, and we spent a couple all-nighters, taking images of Andromeda and a whole bunch of, like pinwheel, galaxies and all that kind of good kind of stuff. So I didn't get what I wanted to do for this observation party. So you'll just have to wait until I get it all back together. So anyway, I've got a lot of good pictures. but nothing for the radio astronomy. But the radios, the radio telescope in the backyard is still collecting data with Alex's or with Ted's new software. We'll see what happens with that. Now, one comment I would like to make is that changing the integration time, it needs to be within the coherence of the waves that are arriving to the antennas. Okay, and if you just randomly take those numbers, you may not be, because the wavelengths are so long, you may not be at the peak of the wave or sampling at the same, area of the wave. It's like
Yeah.
the,
Sorry, Robert. It's it's
Yeah.
Andrew again. So it's Andrew here
Yes.
again. So could you start that again and just explain that in sort of like smaller words? The coherence
Well,
bit.
the coherence of the wave. Okay. Now I'm taking my reference for the coherence is from what's coherent with the optical. Okay, and when you look in the optical, the coherence of wavelengths is the optical waves are in the milliseconds. Okay, because they're much shorter, and the hydrogen is a lot longer. It's 21 centimeters. Okay, so so the wave peaks. It's like when you're doing an interferometer and you're taking the two waves, from the apertures. Okay, you have to do path length compensation so that you can get to so that you can get to image or sample the same the same wave, the same at the same time. Because if you don't do that, when you go to put the two powers together, they won't match. You won't get the correct interference pattern. And it all goes back to Young's double slit experiment as to what happens. Okay, when you do that, and trying to explain that, right now, I haven't sat down and figured out what the coherence of the radio waves are. So so by changing the integration samples that you're taking, the time that you're doing that, you're getting multiple waves, trying to put them together, that makes sense. Okay, so your sample needs to be closer to sampling the same number of waves. If that makes any sense.
Well, largely, Ezra and EasyCall are just counting photons, power coming down from above. So that's just energy. We're, of course, measuring it at different frequencies, but that's fine. And
Yes.
the time period that we're doing that on is long compared to any interference issues you're speaking of. And it's not even related to pulsars, which is a time period issue as well. So
Yes.
I don't see what you're going at. I don't see how it applies in our case.
Sounds good.
So
Thank you.
so carry on with confidence is what I say.
Anyway, that's basically it for me right now until the next meeting.
Okay, great. Did you have a recommendation for integration time for hydrogen?
Not right now, but I'm
Okay.
working on it in
All
the
right,
background.
That'd be
Soon.
fun.
Yes.
Okay, thanks, Robert. Let's see, Detlef.
One moment. So I hope you can see me.
We can.
Okay, what is it's enough light. Yeah, I think I have some results for my phase shifted antennas. So maybe if you want, I can explain a few things.
Okay.
Okay, freigeben. I hope it works. Okay, can you see my screen?
Yes.
Okay, at first I couldn't use a mirror because I have a small roof terrace, and I think I couldn't use a very big antenna. So I think maybe I tried to use more small antennas and a phase shifter system to move the view of the antenna. This is a typical thing. If you hear something about the new mobile net G5, I think it's working with phase shift antennas too. Okay, very easy. I have 8 antennas. 8 LNAs, 8 phase shifters, and a few 8 switchers, which you couldn't see in this picture. Two combiners with 4 channel, 1 combiner with 1 channel, and then a bandpass filter, additional amplifier. SDR, I use a Pluto, and at last I couldn't see it. I use a Raspberry Pi only for measurement. Okay, now I can show you the picture of my setup. Okay, here you see the antenna arrays, and 8 antennas. I think every antenna has 8 directors. I think it's a patch antenna. It's made from brass, and I cut all brass things by hand. I don't have any machines, so I take I think brass scissory or whatever to cut it around. I think it works. This is a case for the metal case for the Raspberry Pi. Below it is Adam Pluto, the power station, and some additional wire. I need this metal case because Raspberry Pi have very strong dispersion signals. And if I use a normal plastic case, it don't work. So I have to use a metal case. And one moment, please. And here on the right side, you see this second box. In the box, I have the phase shifter here, 4 in one box. The bandpass amplifier and an RF relay and a more stuff. And close to the antenna, I have an LNA and a switcher, the RF switch, the switch between reference 50 ohm signal and the antenna, and all thing is covered in with I don't remember in a drain pipe. It's very easy and cheap, and it's waterproofed. So I think normally no water comes up to the LNA and makes any problems. I think this is a setup. It costs a bit of time to optimize it, but I think now it works. And I think I can show you a few results. This is the first measurement without phase shifters at first. This is raw data. This is the line for hydrogen. And I think this is a signal from hydrogen, and this is a signal from the LNA and from the Raspberry and from the Adam Pluto. I think integration time is from my side 180 seconds. So it means I make a measurement for 180 seconds, and then I take the results into the software to work on it. And after filtering, I think I get a signal like this. I think you see a very good signal, and the signal comes from the hydrogen. Okay, the next step was to use the phase shifter. Phase shifter means I could move the view of the antenna. I hope so. And now I take one picture, I think from software, which is mentioned in this group. And sorry. At first, I don't use any phase shifter. At first, I move the antenna in the direction. If you look at top, I think I could move the angel, and so I can make different elevation steps. So, okay, this is a results drift measurement for several days, or for a few days, and every line is a different angel, evaluation angel. Yeah, and so I think I find the Milky Way. At first, it's very important for me, so I could find the Milky Way, and then I think the next step is to switch on the phase shifter. Now I'm using. I hope I could move the view of the antenna by the phase shifter. I think this needles at first the same result. I find the peak of the hydrogen, and I think the signal from after filtering is very good too. And now, okay, I make additional RF measurements to understand better my system. So at first, I think there's no saturation for the Adam Pluto. So that means the signals I could measure are not too strong. So I could, there's no saturation. I make some measurements with 2 RF signals. Okay, if your RF signals are too strong, I think you find some IMD3 modulation. But for normal signals, I think there's no effect. Other thing is, so now I have to eliminate the picture here. One moment, because I couldn't see my slides completely. So now it works. Okay, and then I make some noise measurements with only without any signal. I have a reference, two different reference, and I think I have a strong signal from the antenna. I have a strong signal if I use an 50 ohm resistor in front of the phase shifter. And I have a low signal if I use only 50 ohm reference without the phase shifter. So I think the phase shifter has a strong influence to the noise temperature. So I think it's not understood. I think it works, but I have a very strong effect from the phase shifter. So I think there's something more work for me to eliminate this effect. But I think it's not understood up to now. Okay, next thing is a drift measurement for several days. I think I make a drift measurement for 5 days. And you see here, I change the phase, the electrical phase during the measurements. And if I put this results in this diagram, I think I find the Milky Way again. And you see, I think here's the signal. If the angel is too low, I think the signal is weak, and it's increasing with higher elevation angel. And so I think at first it works, something to do. I think at first is temperature dependence. I don't know it exactly. So next steps for me is at first I try to understand and evaluate the influence from the phase shifter to the strong noise signal. And one thing is, it would be easier to make automatic temperature measurement at the then Pluto, at the phase shifter, and at the LNA. But I think that's the future for the next weeks, I think. So that's my results.
Anybody have any questions for Detlef?
I'm not convinced that Detlef is an amateur anymore. That's very impressive. Looking
okay,
great.
I think it takes much time. So my background is I'm engineer for RF electronic and for semiconductor industry from the semiconductor industry, and so it is very interesting for me. And so it's take a bit time, but I think it worked very good. I think something's wrong with the phase shifter. I'm not sure. Maybe I have to calibrate the phase shifter, but I think it takes time.
Have you noticed that have you tried it with just like 2 antennas and add a couple more and then a couple more and a couple more and see if the gain you get an increase in gain?
Okay, I could switch off all antenna. I could switch off the LNAs for each antenna. So I think I find that this is additional more information, but I think I have to make more measurements. It's too early for me. This is the first results.
It looks really good. All right.
So I have a question or comment. So each one of your cables that you're feeding an antenna, are they all the same length and match?
Yes, they are matched, yes.
Mm-hmm. And inside the box too. So you can't have a temperature, or potentially you could have a temperature effect on the dielectric of the cables, I guess.
Maybe, but I think the wavelength is 23 centimeter, and if the length change to 4 millimeter, a few millimeters, I think there's no influence. I don't think so. I think no. I think the cable is matched, and the phase shifter, I could change the phase shifter from 0 to 360 degrees to 360 degrees, and maybe I have to match it better, or I have to find offsets. But I think this is very difficult for me to find offsets in this complete structure. If I use only a phase shifter and you take one at 0 degree and one at 80 degrees, you compensate the signal. That is very easy, but I'm not sure of if everything, that means antenna, LNA, and so on, has the same effect. I couldn't measure it. I don't have enough splitter to split a signal into 8 different signals to find is there any mismatch in the phase shift. I couldn't find it like this. Maybe I have more ideas, maybe later.
Do you have any temperature data on the splitter to know how well it splits?
Okay, the temperature. The outside temperature, you mean?
Yeah, how the temperature would affect your splitter's ability to
I don't know. I don't know.
signal.
I think the temperature outside on our terrace changed between today 18 degrees in the night to more than 40 degrees on during day. So I think it's a strong effect from temperature. I think so. But at first I try to measure it close to the Bluetooth, close to the phase shift, and close to the LNA, and then maybe I could find some correction. But I think it's future.
Type of phase shifters do you use?
I think I use digital phase shifters. One moment, please. It's from, I think from, I don't know, PA, what maybe.
Was it mini circuits? Mini circuits, maybe.
Yeah. No, I think I use I buy complete modules from in China. I think it's about $50, $50 for each module. I couldn't solder small chips like this. I have no reflow possibility, so I couldn't work on it. I think the phase shifter is PA44820. I don't know the company. I think this is okay. In CMOS technology, 8-bit. Normally from 1.7 to 2.2 gigahertz, but I think it still works at 1 gigahertz too. And I think I take SBI bus for the 8 phase shifter, as they are completely in parallel, and with a normal program for SBI, I could change the phase of every of the phase shifter. This is it takes time, but I think this is very easy.
Have you with your platform fixed? Have you figured out how many degrees of beam your beam steering can be with your
not yet.
setup?
Not yet. I think it's one of the things.
That'd be fun.
I suppose 30 degrees, but I'm not sure.
So you have an array of antennas.
Yeah.
What spacing did you choose, and why?
I think I choose spacing is 1 lambda. If the distance is bigger, I think you get problems, or you go into the area of interferometry. Because then if the space is bigger, you get I don't remember. Sorry, my English. You get minimum in the view. You get many minimum, I think, flying or whatever. I don't know what's the typical typical word from interferometry. But
perhaps fringes. Fringes is what
yeah. But if the antennas are close enough,
show us the picture of slide 3, probably.
Yeah.
So we can see it.
Yeah.
And is that really 21 centimeters apart?
Yeah. Yeah, from here to here, I think 23 centimeters or something, and from here to here, 23 centimeter too. Okay, I could enlarge it, but I think if I enlarge it, I get the problem from interferometry, and our roof terrace is only 6 meters, and so I think I couldn't split the antenna very fast, very far away, so I have to use a.
And if your phase shifter can only do, 180 degrees both ways, then that should account for it for 1 wavelength apart. Yeah, I see.
Yeah.
You chose to have 8 of them, which is fine. And you chose to use that for the vertical direction. Was there a reason, vertical or horizontal? I wouldn't know.
Okay, horizontal. I think I make a drift measurement, so I get more and more, and I get more points. In vertical, I could change only the view by electrical results, and maybe in future, but future is far away. I try to calculate the real. How to explain it? I think you have a characteristic of the antenna, and maybe you have a characteristic of a star. Maybe the Milky Way was with only 1 point, something like this, only for explanation. And then you get a result which depends to the 1 point and the results of the antenna. And if you know the characteristics of your antenna, you could recalculate the real view of at sky. that's in future. It's very, very far away from my side. I think you this for me. Oh, yes, Fourier transformation, you could recalculate it, but I think this is for the future.
I think this is very ambitious. That's great. I look forward to your future results and successes.
I hope it works, but maybe it's a very good, very nice hobby for me.
Sorry, can I ask a very basic question, Detlef? So if I understand it, the phase shifting allows you to effectively change the angle that your aerial array is pointed at.
Yes.
In your computer.
Yeah.
But doesn't that mean then that you're collecting data at less than optimal angle on the aerial? I mean, I assume most aerials work best if they're pointed straight at something, or at 90 degrees to that, depending on what you're actually collecting and why. So if you're at some sort of intermediate angle in between, wouldn't that mean that you would get a weaker signal? Forgive me if I'm asking a basic question.
No, it's okay. But I think it's only an idea to find more, to change the view of the antenna. That is the first thing from my side. So that was the idea. Maybe yeah, no, not this. Here, I think here you can see the result. In my opinion, this is okay. 0 degree don't work. So I think maybe after 30 degrees elevation up to 90 degrees is possible. Yes.
Yeah, I mean the reason I asked the question again, forgive me, my knowledge of matter is not very good, but it's because you were saying that down to the 0 degrees it wasn't performing very well, and I just wondered how much of that poor performance might actually be due to the fact that the aerials were not working at their ideal direction for detecting signals.
Okay, in future I could start at at higher angle. It works, yes, but I think for the first thing, it's only a try to see what happens at first, only to see what happens for learning at first.
No, it's fine. Forgive me for asking the question, really.
No, it's no problem. I think I get results in this area too, but I think the signals are too low, and it's only black dots. So I eliminate these dots.
Okay.
I have more points here. The complete area is complete full, but I think the signals are too weak. So if I get only black points, I think it's not interesting. So I eliminate the black points.
Well, thank you for humoring me and answering my question.
No problem.
Appreciate it.
Okay.
All right. Excellent work. And I hope to see more of that now.
Okay.
Okay. Dmitry.
I think at first I have to stop presenting.
Hi to all. Thanks, Rich. I want to say words of appreciation for well-conducted Green Bank conference, to moderator, Ted and Bob, and certainly to Jay Wilson. We just downloaded courses by Jay Lockman, by Professor Lockman about radio astronomy. Some of the lectures were very interesting. I continue observations of Cepheus A measure and 6.7 GHz. Just a moment. Continuing observations. This is still very interesting measure, and moreover, my 1 year ago data with old 1.8 meter dish were collected, and variability characteristic of these masers were confirmed by almost noiseless data from Japan, Baraki IMET data, very close variability indexes for the measures between red shifted and blue shifted part of the spectrum. And correlation coefficients, correlations between these major parts also confirmed by Ibaraki data. I expected more significant correlations between red and blue parts, but Ibaraki data confirm these correlations, and this measure is rather complicated combination of radial movement of code, of molecular code in this measure of radial movement and rotational movement around excitation center consist of 5 different lines, features. They are distinguished by Japanese very long base interferometry instruments in Japan. 5 different features with different velocities. So, and my simple spectrum with 2 parts and correlations between parts confirmed by the Baraki data, and such low, unexpectedly low correlations is due to very complicated movement, and this measure can be explained. This new instrument, my new instrument for observations, the 2.4 meter dish, designed for millimeters by Radio Whiskey 3 Bravo Papa Sergei Zhukhaev. I have no possibility to use it every day, but at least one in a week I can do my observations. Aperture efficiency of this dish is measured by solar measurement using data from Lidman's observatory in Australia. Rather narrow beam of this dish, so the beam finishing factor is applied to do estimations of aperture efficiency and moon measurement of system temperature. This is obtained 110 kelvins. This is estimated. The system temperature is a little higher, and the system equivalent flux density is calculated from system temperature, and aperture efficiency is about 100,000 Yansky, better than my older instruments, almost 2 times minimal detectable peak flux of with this dish is about 80 Yansky, 1 hour of integrations, and resolution bandwidth about 5 kilohertz. And fresh data with this method from June to end of August, just yesterday data. Mother seems still variable, maybe less dramatic changes than 1 year ago, but some changes I have observed in this measure during the last two months. Left spectrums with small higher, more large scale, about 19 Yansky. This is about 16 Yansky maximum. Okay, this is all.
Thanks, Dimitri. Any questions? Well, good work at good Maser stuff. Okay.
Okay, thank you.
Thank you. Let's see. Let's go with Jason. I know you got some stuff for the 20 meter, I think.
Yeah,
Jason,
sorry.
there you go.
I had to reboot my machine. Okay. Yeah, I've got something here. Let me bring it up and then I'll share my screen. Yeah, I've never had that happen before, but the session actually froze on me and I had to completely reboot my machine. So okay. Just waiting for it to come up here. Bottom line is I've been really busy with the 20 meter scope at Green Bank. Okay, it's taking a minute to launch. Hey, Rich, I may need to let you go to somebody else and then come back to me because it's taking a while for the PowerPoint to launch. So
Ted.
I have nothing particularly to show. I just enjoy these. It inspires me in lots of ways and makes great ideas. Ezra keeps working along. I'm working on a graphical interface to try to help folks just starting out who would prefer not to use the command line. So we'll see if I can make something happen there. I'm working first on the easy call for collecting part. I'm working on a 3 antenna array, not 8, and I have no phase shifters, but I do have 25 feet now between the 3 antennas, and so we'll see what happens. So far, I have to send it more voltage, I've learned. It's a long cable at that point. So we'll see. Future adventures. Back to Rich.
Okay. Jason, you ready?
yeah, I'm up now. It
Okay.
just took me a minute to get it. So I'm gonna do, let's see, I'm gonna share my screen and then let's see here. Let's just do my whole screen. Yeah. All right. So now I'm gonna go ahead and start the presentation from the top here and yeah, okay. So Can everybody see?
Yes.
All
Looks
right.
great.
All right. So what I did is once I kind of figured out how to capture extragalactic hydrogen spectra using that 20-meter dish, I then started a systematic safari hunt, so to speak, to capture all the ones that I could that were in the 2 reference surveys that I used when I was planning my observations with my backyard setup. And so, and obviously the 20-meter dish has a lot more sensitivity and a lot more aperture, so I was able to gather a lot more. Well, I'll just give you the bottom line. I actually captured 30 separate galaxies in the last couple of weeks. So this is a picture of the scope at Green Bank, the 20-meter scope that we can access through University of North Carolina Chapel Hill's Skynet program. And as you all have, I think, heard, Sarah purchases so much time every year on that, and Steve Zekas is kind of the one who administers that for us. And so anyway, I've been using it. I've been using the L-band receiver and using high resolution spectral mode. And then for most of what I would do is, for a default, I would use a 1 second on, 1 second off approach, and then repeat that 10 times. So I'd have a total of 10 seconds of integration time on target. And then my reference was 10 seconds off target. I usually used a 3-degree as-L offset for my off-target point. For some of the smaller ones, I tightened it up to 1.5 degrees off. The beam width of the antenna is about 0.75 degrees at the hydrogen line frequency. So, and then for some of the weaker sources, I went back and cleaned them up by repeating observations with longer integration times, either 50 or 100 seconds on target. And it worked quite nicely. And so I'm just going to dive right into the results. And I have these ordered in descending order of brightness, or in strength of the hydrogen signal. So I started with M31. Now M31 and M31 was challenging because it's too large to fit in the beam of the antenna. So what I did is I took 3 points, I believe, maybe 4. Anyway, I took a number of points that overlapped somewhat, and then I kind of I basically summed them together to get this profile. The horizontal, in case you're wondering, the horizontal axis is velocity, and it's corrected for VLSR. So the motion of the Earth, the orbital motion of the Earth, it has been removed. And so, and then the vertical axis is what just by default comes out of this application mode on Skynet with that antenna, which is it's power in Kelvin, so it's been converted to temperature. Now I did have to correct background because the background, when you get down to low levels, the background does slope or slant or move around, and so I did correct background using basically areas on either side that I knew were flat, and flattened the background in the region that I was interested in. So M31, M33, and as you will see, the vertical scale will decrease each one. M33 just barely fits in the beam of the antenna, and so I could get the whole thing in one shot. M101, and that's basically the first 3 that I got with my backyard setup. But unlike my backyard setup, which I was on target for multiple days and total of integration time of several hours, this was literally 10 seconds on target. So yeah, 60 feet of aperture does a lot. And then here's M110. M110 actually was not in the surveys. It's that small satellite of M31, and it's small, but it's bright. And so I was able to get a decent spectrum for that one. And as you notice, if we go back to M31, it's if you look at the center of the spectral profile, it's about 300 kilometers a second negative, and that's the same velocity that you get for the peak of M110 because they're both in the same gravitationally bound system, so they're both moving towards us at the same speed, basically. Now we have NGC 3109, IC1 or IC10, M74, M81. Now M81 is interesting because its motion with its radial motion from our vantage point is nearly zero. It's very small. It's a very small velocity, and so it's actually centered on the hydrogen frequency, or on the basically the unshifted hydrogen frequency. And so the Milky Way signal is right at zero, or very close to zero. And so that big vertical disturbance you see in the center around zero is the residual Milky Way signal that's kind of still there. Using the off-target reference removes most of it, but not all. And so there's always a little residual there. And so you'll see if the spectral profiles that I'm looking at contain zero or they're close to zero, you'll see that Milky Way signal still there. M82, NGC 2403, and it bumps up right against the Milky Way, so you can kind of see that vertical line from the Milky Way, but then most of it is actually out to the right, and so it's slightly redshifted, but not a lot. Now we have Holmberg 2. We've got NGC 3077, 4214. And the satisfying thing, I didn't put it in this presentation, but at the end, I have references to both of the surveys that I used as my field guide, so to speak. And those have integrated spectral plots for each of these. And so it's really cool to compare the two, because the shapes and the location in the Doppler shift match, and it's just really it's satisfying to kind of see, hey, it matches up. And as you'll probably notice, we're getting smaller and smaller amplitudes, because we're getting into farther and farther ones that are a weaker signal. And when I got down to this level, I had to start using 50 and 100-second integration times to clean them up. So yeah. And just another thing to note, when you see this two-horn profile, it's the Doppler splitting because of the fact that it's a spiral galaxy that's spinning. So there's a red shift and a blue shift at the same time, splitting the single peak into two. And the width of that profile gives you some indication of the orientation, whether the galaxy is edge on, it will be really wide. If it's more face on, it'll be narrow. In fact, if it's directly face on, then there's no Doppler shift at all, and you get a single peak. And so and there's my my references. These are the same surveys I used in my 3-meter paper as well. So I hope you guys enjoyed that. And what I'm planning to do for the Drake's Lounge in a couple of weeks is put together a detailed presentation on my methods, so that other people can understand, so that the community at large can understand how I'm making my measurements and why I made those decisions, and then also to make it a how-to guide for other people who want to do it as well. So stay tuned. That's going to be coming soon. Let me go ahead and stop sharing. And yeah, so any comments, questions?
Can I make a couple of comments?
Sure.
I think your work is very interesting. And it's interesting to me to see that you're measuring, you said it in Kelvin, so you're getting down to less than 1 degree Kelvin, I guess, in your comparison with your reference and your
Yeah.
and as you get lower in the signal strengths, the noise level comes up. You can see that effect happening there. And your comment that you increased your integration time to sort it out was interesting too. So it really shows a lot in this presentation about how to do some pretty sophisticated things in radio astronomy.
Yeah, well, yeah, definitely. What's really satisfying to me is to see the theoretical stuff playing out in real life. So for instance, I didn't show it in this one, but when I put together the how-to guide or the my method presentation for next time, I did do a side by side. I did 5 different captures of M101 with varying integration times. So I started out with 2.5 minutes on it because I didn't know how long I would need at first, and I was using way more. I was using way more time than I actually needed to get a clean one. And so then I reduced it to 30 seconds, then 10 seconds, then 5 seconds, then 1 second. And I can click through those and kind of show how the noise increases or as you decrease the integration time. And it's really satisfying to see that 1 over n squared law work being illustrated in actuality. You know, it's just kind of neat to see. So
Yeah, and you can do a lot of things with your data too. Like I guess you could compare the distance to the source and with your velocities. And
yeah. It's funny. Like the brightest ones, well, at least M31 and M33 are close enough that they're gravitationally bound, so they're actually blue shifted overall, right? But once you get beyond that, you start getting to they're all redshifted. I mean, anything from M101 on, they're all far enough away that they're starting the Hubble expansion is starting to become a factor at that point, right? So it's that, which is pretty neat to see as well.
sure,
Yeah.
Jason, you've been able to using the blue and the red and the shift between the each edge of the galaxy. Can you tell what the angle is? Can you calculate that?
So I need to look into that more. I mean, qualitatively, yeah, you can tell it. You can tell it in a very general sense whether it's more tilted or less tilted. But to actually do, something more quantitative, I'm gonna have to look into that a little more in a little more detail. I suspect that there's going to be some either assumptions or additional information you will need to know. For instance, you would need to know the distance and the angular size so that you could correlate, apples to apples as far as the rotation curve, because that's gonna affect your separation, right? If it's a small galaxy and it's close, it's gonna look the same size as a larger one farther away, but the velocities are going to be vastly different, right? And so yeah.
Along that line, the rotation rate of the galaxy, can you figure that out? And if you can figure that out, you can figure out the mass of the galaxy.
Mm-hmm.
And so there's all sorts of information that your plots. If someone takes these plots and starts to calculate some of that stuff, you can have all this information about galaxies just with your measurements.
Yeah. And in fact, that's why, I mean, they started doing surveys in the late 60s, I believe, but the first of my 2 references was actually a survey that was completed in 1974. And then the second one is a 2008 survey that was done with the VLA. And of course, it's very high resolution spatially, but the integrated spectra are also provided. And so what a lot of these surveys do is they just gather the data, put it out there, and then other researchers use that data then, like you said, to do various measurements for different types of astronomical work. So you like you said, the rotation curve will start to give you information on the total mass, and then there's like I said, there's a lot of research that basically these surveys are kind of like feeding raw data into hundreds and hundreds of papers probably. So that's pretty neat, So
Yeah, this is all good stuff.
One other question, are you doing this mostly in the daytime or the nighttime, or do you notice a difference in the results of day versus night?
I haven't really kept track of whether it's daytime or nighttime. I did though have one that it didn't run, because you set limits on minimum elevation. What you do is you queue up your measurement, you set it up, and you set limits. You say, okay, I want it to run at a minimum of 45 degrees above horizon or something like that, right? And then what it'll do is if it's already in position and the scope is available, then it will do it. But if it's not, it'll just save that it'll queue that up and wait until both of those conditions are met. And I had one where it was well above my minimum, but it wasn't running, and I checked the status on Skynet, and it was idle. So I was like, why is it not running? And then I realized my object was less than 20 degrees from the sun in the sky. And the default is like 30 degrees, I think, from the sun. And so I reduced that to 10 degrees, and then it went ahead and ran, and it worked fine. So even fairly close to the sun, I didn't have any trouble with this. And part of it is that because I'm using a very closely spatially offset reference point. So I'm using on-off mode. So I'm centering the object and then offsetting the beam by like 1.5 or 3 degrees in each axis and doing a reference. The only thing I guess you lose from perhaps from the sun, if you're getting some bleed over, is SNR. But because you're using the reference actually close to the object, it's kind of calibrating itself, as far as background goes. So you're probably suffering as far as like sensitivity, but it all washes out when you use that off target reference, which also helps get rid of a lot of the Milky Way and make some of these ones that are really close to zero redshift or blue shift actually possible to separate from the Milky Way, because otherwise the Milky Way would just like bury it.
I would think that your reference or with your system would be even sensitive to cloud cover blowing over. So like the scope gets in a shade of a cloud and then it passes by. So that could influence your results too a little bit, I would think.
Yeah, I think though that you're not going to notice any of that kind of interference with the on-off, because it's basically calibrating itself relative to the off target. I think you're only going to notice that if it dramatically affects your sensitivity, because like I said, the reference is moving at the same, whatever's affecting the reference is also affecting the on target. And because I'm doing those 1 second apart, I'm basically doing 1 second on, 1 second off. There's almost no time between those, so there's not a lot of time for the background to change a lot, I guess. I did notice, which is something I will talk about next time in my how-to, when I show the longer time integration time capture on M101. Originally, I did 2.5 minutes on target in one block, and then 2.5 minutes off target in one block. And over that time, it has more time to move and drift. And so the background is a lot more warped and curved than when I did it with 1 second on, 1 second off, and then repeating that multiple times. That kept it a lot flatter, reducing the time between calibration steps. So yeah, I've been learning a lot about how to take these kind of measurements and get good results with the minimum amount of telescope time, which is great. I mean, for a lot of these, I can do 30 seconds, to a minute total, and I can get a good spectrum for a lot of these ones in the mid range. And so I think there's a lot more galaxies. I've been looking at. I actually downloaded a copy of the entire NGC and IC catalogs, and I posted those into my spreadsheet that I'm using to keep track of my survey galaxies from the survey papers, and I've matched it up, and then I'm ordering those by visible magnitude, which sort of generally tends to track with strength of hydrogen signal. And so I'm finding that there's probably a good 50 more galaxies that are within the reach of this scope with only, less than a minute of integration time. So I got more more available, I guess, to go after. But
All right, great work, Jason.
thanks.
All right, all right, Chet Mitchell.
I am in the process of building a second Despira telescope right now, but it's not ready yet. I'll share about it at the Drake's Lounge meeting later in the month.
Okay. Great. Let's see, Don Latham. Okay, we'll get Don later. Oh, there?
I haven't got anything to report, so that was quick.
Good. Okay, thanks. Helen.
Did you call me?
Sure.
Oh, I'm sorry. Can you hear me?
Yes.
Oh, okay. Oh, as usual, I'm sitting here in awe, but I am learning. There's so much interesting information. The tapes that were recommended at your conference by Dr. Lockman, I went through those. I need to go through those a second time. But what really intrigued me was the presentation you had last time, the Riesa Technical University and all the work they're doing over there, because I have family over there. And in fact, they just got back here 2 weeks before this, and they'll be back in January, and going to send them over there and check it out. And it should be really fascinating. And I know they'll get a lot out of it.
All right. Thanks,
Yeah.
Helen.
And talk about being in the right place at the wrong time. We'll be in Texas for the next 3 weeks. Where the eclipse was. Too bad. It would have been nice.
Well, timing's everything.
Yeah, we know. Thank you.
All right. Thanks. Bruce.
Yeah. Hello. I'm just kind of listening to what everybody's doing. I've been mainly recovering from storm damage, hailstorm here April 20th, and a hurricane, or I guess tropical storm Debbie. The remains of it dumped on me. So that's what I've been up to. Nothing really interesting. So that's about it from here. Really interesting to hear what everybody else is working on, though. It's nice to hear of other people's work when you can't do much.
Great. Thanks. Preston. Preston, you there? Okay. Bob, you got anything else?
Yeah, I have one question. You said that somebody sent out a notice about the dues being needing to be paid, I guess.
We did. We sent out a renewal notice, and
But who would that come
25.
from? What email? I noticed Andrew posted in the chat that he looked for it and couldn't find it, but maybe, do you know who sent it out, or was that?
Well, I
coming from
sent it
Bob?
out.
You did?
The
Okay.
so we currently have been scrubbing the database, Tom and I, and we came up with 652 people that are subscribed, which means we have their email addresses and they're allowing us to send emails.
It would be
Out
an
of
email
that,
from you that we would be looking for. That's my point.
right. Well, Bob, if you I could check for you if you're on there, and
I think
Andrew,
I
I've got
paid.
that on my list for check for Andrew too. It just means that either you've paid or you're either you should have gotten it if you haven't paid, or you're not in the database, or you're in the database. Yeah. So there might be a problem with the data if you think you've paid, or if you haven't paid and you should have paid and you didn't get a notice. So we'll figure that out. But we're down to just having a couple glitches in the data instead of a big chunk of problems. So we got a few people with our biggest problem was having duplicates, because people have two different emails. In our MailChimp account is all off on email. So if they gave us two different emails in the past, then it looks like there's two people there. So anyway, we're working at it. It's just really getting we know where we're at now, and we're just collecting dues as we speak. So it's right on track right now.
Thank you.
Bob, this is Tom Jacobs.
Yes, sir.
Are you receiving the Drake Lounge and the RTOP emails?
No, I don't think I do.
Well, it would come from the same location, so we will have to check on that. We use a service called MailChimp for the mass mailings, and you have some ability to control that yourself back through that. So that's better than us having trying to maintain the list ourselves. But if you're not receiving that and you've just got this meeting and the Drake Lounge stuff on your calendar, the next thing to say is, do you also receiving Sarah journal messages
No, I didn't get those either. I did pay for the Eastern Conference, and I think when I paid for the Eastern Conference, I signed up for my membership at the same time. But,
okay, yeah, that's very common. We'll have to look into seeing why you're not receiving that. But yeah, that's something we can check on.
okay.
Yeah, that's easy. I'll have that fixed by this afternoon.
I'm sorry, I don't mean to be creating any work for anybody.
I think what's going on is Tom and I just got this thing. We just know where we're at now, and now we're getting the little glitches where we're finding out that people aren't getting emails or getting 2 emails, and but those are just like 5 out of 652. So I think that we're doing really well on identifying the little glitches in there, and so yeah, everybody speak up if you're not getting the notices and things like that, because it's easy to fix as long as we know they're there. So I'll get yours fixed by this afternoon, Bob, and Andrew, I'll let you know if you're if you've paid or not by this afternoon, and so we should be there. But this is why we're having these meetings, so we can actually scope out get it fine-tuned.
I'm not getting the emails either, but the only emails I'm not getting is the journal and the notices of the meetings. The just the 3.
That's everything, Helen. Okay, I got you on the list too.
Oh, okay, great. Thank you.
Yeah, what we also have to notice is, so there's the emails coming from Sarah through MailChimp. There's also the Google Groups list server, which is the other thing that happens, and that's separate.
Right.
But we'll just have to check. You know, one of the things to do here is to ask questions, and this is where we get feedback.
Great.
Question here. I've got had problems with my email provider, which is also my ISP. But anyway, they don't like attachments and give me a lot of headaches. I'm thinking of changing over to a Gmail account for everything. And I'm wondering what kind of headaches that will cause for Tom or Rich there when I change over, or what do I need to do to avoid headaches when I change over?
You're going to have to just send us your send an email to Tom and I with your old email that you used to have and your new email, and we're going to have to just basically set you up as a new, change out your account in MailChimp. And I don't know about QuickBooks, maybe the same way, or QuickBooks. We got QuickBooks handles the financials, but also feeds the MailChimp and updates that. And so, but it's the email address that really identifies you, not necessarily your name. So if you change email address, then we have to almost treat you like a new member in the accounts, and then delete you at the old member, your old email. So I think we're just figuring that out. But Bruce, just send us an email saying what you're trying to do, and with your new email address, and we'll work it out.
Actually, I'll add one other thing. Rather than sending it to me personally with my personal email, send it to treasurer@radio-astronomy.org. That way, both Rich and I will see that email when our website explodes that. Those are not real email addresses, they are aliases. And so any single mail to that goes to multiple people. So treasurer@radio-astronomy or radio-astronomy.org. That's where you really want to do it. I think there's also a president, but Rich will have to talk about that. But I have multiple email addresses, and I will get them. They will not necessarily get to everybody who might need to see that. So I will say it again, and maybe I should put it in the chat. But anyhow, so that's the one thing I will warn people. And a large number of people are using Gmail accounts, even though they have other email accounts. I can see in QuickBooks where they've had multiple email addresses. And that's something that QuickBooks doesn't really understand. It really understands lots and lots of phone numbers, but it doesn't understand lots and lots of email addresses. And that's just one of their limitations.
Yeah.
But we work around it. Anyhow, let me put that address in the chat.
All right. Any other questions, either from technical or administrative?
Now I kind of feel guilty about the amount of extra work I'm going to make for you guys changing over there. But yeah, we'll work through it. And yeah, I'm going to wait a bit because I got a whole bunch of things get affected.
Oh no, it's not a lot of work. It's almost like it's easy to fix, but we have to know about it. And that's really right now we're scouring to find out what are the issues so that we can quickly fix them. And I think we've got the database the best we've ever had in 4 years as of today. But now we know where we're at, and we just, a lot of people through the pandemic didn't get their renewals updated. So we got about 460 people that have not updated to 2025. And so out of 652. So we're in that stage now where we've sent it out, and we're waiting for replies, and we're getting a lot in fast. So I think we've got a good, we're getting that in, and we'll send out a second renewal probably at the end of the next month. And we'll see if we can catch some of these other stragglers. Okay, that's all we've got. Thank you very much, everybody, and see you on Drake's Lounge in 2 weeks.
The email address is in the chat. So whatever you need, like I say. The other thing to say is don't feel too bad. This is the job. You know, straightening this stuff is the job.
Yep. And I'm going to double Tom's salary if he gets it right.
Oh boy.
There you go. Okay. Thanks, everybody.